In this video, I am going to solve the problem 27 from chapter 19. A certain gas occupies a volume of 0.76 liter at a pressure of 1.2 atm and a temperature of 4000 Kelvin. It is expanded adiabatically to a volume of 4.3 liter. Determine the final pressure and the final temperature. Assuming the gas to be an ideal gas for which the gamma equal to 1.4. So in this question, they mentioned the process is adiabatic and they give the information of the initial volume and the final volume, and they give the initial pressure and the final pressure. And also they mentioned the gas is an ideal gas and they give the value of the gamma, which is 1.4. Clear? Okay. Now, first of all, I'm going to write the given. So what are the information given here? The information given here is the initial volume. What is the initial volume here? Which is 0.76 liter. And initial pressure, PI value, here they mention as 1.2 atm. If you want to convert it to Pascal, it's simply you have to multiply this 1.2 with 1.013 multiply 10 power 5 Pascal. Clear? So when you just multiply this 1.013 multiply 10 power 5 with this 1.2, you will get the answer in terms of Pascal. So let's see what is the answer for this. So 1.2 multiply 1.013 10 power 5. I got the answer here as 1.2156 multiply 10 power 5 Pascal. So this is the value of the pressure in terms of Pascal. This is our initial pressure. And also they gave the initial temperature, the value of the temperature, initial temperature, they mentioned here as 4000 Kelvin. By using all this, and also they mentioned the gamma value, which is 1.4, and the gas is an ideal gas. So by using all these, we are going to identify the final pressure. That means PF value we are going to find from the first part, and then we are going to find the final temperature in the second part. So now what I'm going to do, I'm going to solve one by one. So before that, we have to recall the condition for adiabatic. We studied two relations. One is the pressure related with volume, and the second one is temperature related with volume. So I'm going to use these two equations here. So first of all, I will write the equation which is related with pressure and volume. That means PI VI gamma, which is equal to PF VF gamma. So this is the first relation I am going to use here for finding the value of final pressure. And in the second part, for finding the final temperature, I am going to use the relation connecting temperature and volume. What is the relation? Ti Vi gamma minus 1, which is equal to Tf Vf gamma minus 1. So this equation we can use for finding the answer for the final temperature. So let's start one by one. First of all, I am going to find the final pressure by using this relation. For that, I have to use this given value. Clear? Okay, let's start. For finding the answer for final pressure we are going to find here. So final pressure, which is PF, we are going to find from here by using this relation. So let's start, and I'm going to substitute the value in that equation. So first of all, I'm going to write the equation here one more time. So PI VI gamma, which is equal to PF VF gamma. We are going to find the value of PF. So I'm going to rearrange this equation in terms of PF. So PF, which is equal to PI VI gamma, and then we have to take this BF gamma to the left hand side. So VF will come to the denominator of the left hand side, and once again, if you rewrite this equation, so we can write this equation as PI VI over VF the whole power gamma. We can write like this also, right? Okay, now I'm going to substitute the value here because we have all the data in the question. So let's substitute one by one. What is the pressure here they give, which is 1.2. So when we convert that 1.2 into Pascal, what is our answer? 1.2156 multiply 10 power 5. 1.2156 multiply 10 power 5. This is our initial pressure in terms of Pascal. Multiply with, what is our VI? Our VI here they mention as 0.76, and then VF is 4.3. So better we can just have a look one more time. So our VF value is, what is our VF value? I forget to write the VF value here. So better I can write it here. So VF value here they mention as 4.3 liter, and VI is 0.76 liter. So I'm going to substitute the value now. And the gamma value they mentioned here as 1.4. So now I'm going to calculate. Let's see what is the answer for the first part. 1.2156 10 power 5 10 power 5 multiply 0.76 over 4.3 power 1.4. I got the answer here as 1.0741 10 power 4, and the unit is Pascal. So this is the answer for the first part. Clear? Okay. Now we are going to find the second answer, which is the final temperature. For this, I am going to use this relation. So B part, we are going to find the final temperature, which is TF. We are going to find. So for that, I am going to use this relation TI VI gamma minus 1, which is equal to TF VF gamma minus 1. So I have to rearrange this equation in terms of TF. Therefore, TF is equal to TI VI gamma minus 1 over VF gamma minus 1. If you again rewrite this equation, so TI multiply with VI over VF whole power gamma minus 1. So now I'm going to substitute the value here. The initial temperature value they mentioned in the question as 4000 Kelvin, right? So 4000 multiply with VI value, which is 0.76, and VF value is 4.3, and the gamma value is 1.4 minus 1. So let's see what is the answer. So I got the answer here as 1999.85 Kelvin. So this is the answer for the second part. So the final temperature value is 1.999 multiply 10 power 3 Kelvin. Either you can write it in the power, or you can just leave as it is. That's it. Thank you.